In this video, I'll walk you through an adaptation of an existing sample that enables custom autoscaling for Azure Resource Manager virtual machines, but gets the sample working in Azure Government. So the blog post does a good job of explaining why you might want to do this, including why you might use this as an alternative to virtual machine scale sets. To get started with this sample, you're going to want to either download or clone this repo, and then open it in Visual Studio. What you'll notice is this is made up of a Azure Automation Runbook, which is just a PowerShell script that runs in Azure Automation, and then a .NET class library, which works around some PowerShell commands not available to Azure Government as of the time of this video recording, which is May 3rd, 2017. Now, of course, once those PowerShell commands work with Azure Government, the original sample becomes very useful. But as is, it won't run in Azure Government. And specifically, there's a command called get Azure RM metric, which if you actually try to run it in Azure Government, you'll get an error because the underlying infrastructure to support this command isn't deployed to Azure Government, again, as of this recording, which is May 3rd, 2017. Just to emphasize again, if you find that get Azure RM metric is available when you watch this video, it would be a good idea to just use the original sample. So let's quickly walk through the PowerShell Runbook. It takes some parameters, namely the name of a subscription, the name of a resource group, a connection string to the Azure Diagnostics storage account, a comma-separated list of the virtual machines that you want to scale out and in, a time range, basically the last X number of minutes you want to evaluate the average CPU, the min CPU value you want to use if you want to scale in, and the max CPU value you want to use if you want to scale out. So I have an environment set up already where I have 5 virtual machines I want to be eligible to scale out and scale in. If you look over here, you'll notice that 2 of those 5 virtual machines are running. If you look at an individual virtual machine, it's already configured for diagnostics. Notice I have it turned on. The storage account I'm using is this storage account right here, and I've got basic metrics turning on, which will send percent processor time. And so if I look at another one of these, you'll notice that consistently across all these virtual machines, the same is being done. I've got diagnostics enabled, and it's going to that same storage account. I'll open up Azure Storage Explorer here, and what you'll notice is that there's a table in that storage account called WAD Performance Counters table that maintains all of those performance counters. So if we go back to the PowerShell script, doing some standard run as connection establishment. In this case, I'm using Azure Government as my environment name. I'm referencing a .NET DLL, which happens to be this DLL over here. We'll get into that in a second. And when I walk through deploying this, you'll see how we're able to get this DLL deployed to Azure Automation, and that this is the directory it gets deployed into. C modules user, a directory called perf counter helper library, and then the DLL is available in that directory. We're setting the subscription, establishing what metric we want to track, establishing some basic variables, getting the virtual machine names passed in as parameters into an array. And then for each virtual machine in the array, we're going to get some information about that virtual machine, like whether it's running or not, set up some basic variables. I'll make a call to that .NET library, passing in the diagnostic storage connection string, the time range, the virtual machine name, and the metric that we're asking for. So let's take a look at that real quick. So what it does is it takes those parameters and it uses the .NET libraries for Azure Storage to basically query that performance counter table based on the partition key, which is date time based. So that's how we get the metrics for the last X number of minutes. And then we also want to filter based on the counter name and the role instance. So an example here, there's the counter name and then there's the role instance. So once we have the metrics we care about, we do some null checking here. We're getting the average of the counter values. If the average is less than the min, we set it to -1. If the average is greater than the max, we set it to 1, and we'll evaluate that value later. Otherwise, we say we don't have any metrics, and then we collect all the values into an array. Once we have the values in the array, we basically dump out a bunch of information. We do some counts, information about all the, the started servers, the stopped servers, the servers that are in range, the servers that are above range, and then ultimately we just use those values. If we only have 2 servers, we can't scale in any direction. If all the servers are in the range, there's nothing to do. If we're above the CPU utilization, we need to start a server, unless there are no servers to start, which is an indication you might want to add an additional VM to allow it to scale out more. Otherwise, we just simply start the server using Azure Powershell. If we're below the threshold, but we only have 2 servers, we can't scale down. Otherwise, we stop a server, again using Azure Powershell. All right, so how do you get all this up and running in Azure? Let's go over to the portal here. First thing we're going to do is deploy this runbook to an automation account. In order to save time, I've already created an automation account. You'd want to create one yourself. So I'll open this automation account. Now, in order for that runbook to work, we actually have to deploy that .NET library. So we'll come into Assets, Modules, and we'll add a module. And the way that you do this is that you take the output of your .NET library. So I can come over here, open it up in File Explorer. In my case, I want to deploy the release, so find bin release. And you take all the DLLs and you send them to a zip folder. I've already done that here. I've got one called perf counter helper library, and that name is what's used to create that directory. So once we've got that, we can come over to our portal and upload it. Click OK. Notice I refresh here, you'll see that it's extracting the activities. So this takes a minute for the extraction process to complete. Alright, in the interest of time and the magic of video editing, I've refreshed and perf counter helper library is now available. Alright, so the next thing we want to do is go back to the root of our automation account here and add the runbook. So we'll create a new runbook. We'll call this Auto Scale Azure Virtual Machines. It's just a standard PowerShell runbook. Create it. You could, of course, import it yourself, but I'm just going to copy and paste it since I have it. I'll do a Control-A, Control-C, paste it in. Again, we uploaded that DLL as a module, which gets deployed in the environment under a directory called C modules user perf counter helper library, and then pointing to the DLL itself. And of course, all the dependent assemblies are there. So let's save this, go to the test pane. We need to provide some values. All right, so I've populated my parameters, and I'll just explain them. We're going to use the subscription name, the resource group that the virtual machines are in. We're going to use a standard storage connection string for the storage account that contains the diagnostics information. And we'll just have a comma separated list of virtual machine names. The time range, we want to evaluate over the last 5 minutes whether or not the average CPU value was 20%, and if it was, we'll scale in. And if the average CPU value was 60%, we'll scale out. Let's go ahead and start this. So it's starting up. Doesn't find any metrics for VM 2, 3, and 4 because they're shut down, and so no metrics are being collected. Tells us that the average processor for VM 0 is above 60. The average processor for VM 1 is below 1. And then for the other VMs, it's obviously going to be 0. We've got a total number of 5 servers. Only 2 of them are started. 3 of them are stopped. There's only 1 above range server. There's 1 server below range. And so in this case, it did nothing. So let's log into those servers. I'm curious why VM1 has such high CPU utilization? I bet you it's a Windows update. It was. So at any rate, let's get it to be above the threshold. So I'm using a handy tool called CPU stress to simulate CPU utilization. And then we'll go to VM1 and do the same. And so let's run this again. All right, in this case, we have no metrics for VM2, 3, and 4, because again, they're not running. The average processor for VM1 is over 91%. I'm sorry, VM0. The average for VM1 is above 60. So this should scale out an additional server. Again, we have 2 started servers, we have 2 stopped servers. I'm sorry, 3 stopped servers. In this case, we have 2 servers that are above the range, so we need to start 1 server, starting VM2, which is the 3rd VM in the series. And VM2 is now started. Now, of course, it takes some time for these commands to run, so I've edited out the wait time. But if you're trying to follow along, this is probably a good time for you to pause and wait for your script to complete. So let's just validate that. Let's refresh here. And notice that we have VM0, VM1, and VM2 running. All right, so let's go back over to the VMs themselves, and let's get the CPU to come down. Now let's go back over to test the script out. Now again, for this to work, you want to give it a couple minutes so that the average comes down. But in the interest of preventing awkward silence, I'm going to go ahead and edit that part out. All right, so again, no metrics for VM3 and 4 because they're not running. In this case, VM0's average processor is below the threshold. VM1's average processor is below. And VM2's average processor is below. Therefore, we should see a scale in and go from 3 VMs to 2 VMs. Again, our total servers is 5. The number of servers started right now is 3. The number stopped is 2. None of our servers are within the range. All of our servers are below the range, therefore we're stopping 1 server. Again, in the interest of time, I've cut out the time it took to actually stop the server, but we can see that the server stopped. And just for a sanity check here, let's refresh. We can see that where we had 3 running, we now have 1 stopped and we only have 2 servers running. All right, great, but we've been testing this out manually. You're going to want to execute this runbook on a recurring cycle. So let's first publish it. All right, so it's eligible to be scheduled. Now we could come in here and click schedule. You'd have to create a new schedule. Now if we make this a recurring schedule, you'll see that the Azure Automation schedule feature, the lowest recur value it allows is once every hour. For some, checking every hour may be good enough, but I suspect for many you want to check whether you need to auto scale at a much shorter interval, maybe 5 minutes, 10 minutes, 15 minutes, etc. So in order to do that, one approach is to enable this as a webhook. So when I click webhook here, what we'll do is we'll create a new webhook. We'll give it a name. It's going to be enabled, and we want to copy this URL. Click OK. So we need to specify the parameters we want to pass to this runbook. All right, so I've used the same values as last time. I'll click OK here. And now this runbook is callable from an HTTP post. And one way to do that is to use the Azure Scheduler. So we'll come over to our resource group. We'll add a schedule. We'll call this auto scale schedule. We don't have any Azure job collections yet, so we'll create a new one. Auto scale job collection. I'll put it in our existing resource group. Needs to be a post, and then it'll be that URL of the webhook. And then in the body, you could pass additional information. You could even pass like an API key and validate that on the other side if you needed to, but we'll keep it simple for now. I'll click OK. We'll configure the schedule itself. It'll be recurring, and we'll say every 10 minutes. It never ends. I'll click OK here and create. So once that deployment's complete, we now have a job collection. And if I look at the job, I can look at the history. This job hasn't run yet. So let's just go ahead and run it. And if we look at the history again, I'll see that it completed. So this basically just made the webhook call. If I come back over to my automation account, let's take a look at the runbook jobs that were executed. So looks like it's running based on the webhook call. And from here on out, that runbook will be called every 10 minutes, and it'll look back over the last 5 minutes of CPU utilization to determine whether to auto-scale. Now you could change the frequency that the runbook runs. You could change the time history that the runbook uses to look back. So you could say every 10 minutes. You could say, frankly, whatever you want, and you can play with those values. All right, so in this video, I showed you how to use Azure Automation to auto-scale Azure virtual machines running in Azure Government using an Azure Automation Runbook, which makes a call to a custom .NET assembly to get metrics as a workaround to the inability to call the get Azure RM metric PowerShell command when targeting Azure Government. Now, if you think about this general approach, it has applicability beyond just Azure virtual machines. Right, so we're able to auto-scale without using VM scale sets, but you could also use this to auto-scale VM scale sets because those are available in Azure Government today. And again, as of this video recording, which is May 3rd, 2017, VM scale sets are available, but you can't auto-scale them today. So you could use this approach to auto-scale VM scale sets. You could use this approach to auto-scale Azure App Service. You could use this approach to auto-scale Azure SQL Database, etc. Right? Because once you have access to the metrics, you can implement any sort of logic you want in your Azure Automation job. And similarly, while Azure Automation is not available in the Azure DoD regions, you could certainly take this approach and run a PowerShell script using the Windows scheduler in an Azure virtual machine. So this general approach to auto-scaling has broad applicability as an alternative to the individual service's native auto-scheduler. And in some cases, you can use it because they aren't available in Azure Government today, and in other cases you may want to use it because you have more granular control over how auto-scaling happens.